Okay, let's look at some basic EIGRP configuration. So here's our topology that we're going to be using. Okay, so first of all, let's look at R1 as far as its interface configurations. And you'll see the IPv4 addresses on this. And again, this is configuring EIGRP for IPv4. You'll notice that we have some serial links here with some pretty slow bandwidth, but that's okay for demonstration purposes. But the reason why we're doing this is to remind you that, remember, EIGRP uses slowest bandwidth plus the sum of the delays. So it's important to have the right bandwidth value configured on our serial interfaces. Serial interfaces on some models may default to things like 1.544 megabits, and as far that doesn't mean that the actual speed of the link is 1.544 megabits, but the value used in the bandwidth for routing metrics will default to that. So remember, we used that value, show interfaces command, when we looked at the composite metric for EIGRP. So the point here is you need to make sure on the interface that you reflect the proper bandwidth for your serial interfaces. Okay, we do the same thing on router R2, and we do the same thing on router R3. Okay, and this is something we typically only have to do for our serial interfaces. All right, so let's configure EIGRP for IPv4. So EIGRP, similar to OSPF, uses something called a process ID to represent the instance of that routing protocol process running on the router. EIGRP actually refers to that value as an autonomous system number, but it's not really an autonomous system number. It's just a process ID. It's just something that we use within our own routing domain to represent the EIGRP process. It's a number between 1 and 65,535. Okay, and the key thing with EIGRP is this must be the same value used on the same process ID must be used on all routers in your EIGRP routing domain. All right, then we're going to use the network command to actually enable the router to route networks, okay? To enable the interfaces and to announce which networks will be advertised by that router. So the network command, so let's take a look here. So for example, network 192.168.10.0. What does a network command do? Okay, one thing it does is says any interfaces on this router that matches this network address will be enabled to send and receive EIGRP routing updates. Now this is the same, this is true for all IGP, interior gateway routing protocols, RIP, EIGRP, and OSPF. The network command works the same. By the way, BGP, an exterior routing protocol, it works, the network command works differently. Okay, but so getting back to EIGRP, it says, if I have any interfaces that have an address that falls under 192.168.10.0 within that network, then it's going to be enabled for EIGRP. Okay. It also says I will announce that network or subnet will be included in my EIGRP routing updates. Now, you see here in our example, network 192.168.10.0, there's no wildcard mask, which is we're going to talk about next, is the inverse of a subnet mask. When we do not use a wildcard mask, what EIGRP does is it says, I will use the classful mask. So this is, in the old days, a Class C network. So the default mask would be 255.255.255.0. What that means, if I have any networks that are in that network or a subnet of it, any interfaces fall within that network, they will all be enabled for EIGRP. Best practice, use a wildcard mask. So let's talk about what a wildcard mask is. And I think Cisco iOS is beginning to move away from wildcard masks and just go back to even using subnet masks on these. So what a wildcard mask is it's basically the inverse of a subnet mask. So to calculate the wildcard mask, you take quad 255, subtract the subnet mask of the network, and you get a wildcard mask. So when you use your network statement and you want to specify a specific subnet, maybe a specific subnet, an interface on a specific subnet, you use the wildcard mask instead of the subnet mask. However, on many iOS versions, you can actually use the subnet mask and it will take it, but in the running config and startup config, what you'll see is the wildcard mask. Cisco did this many years ago to kind of make us think that to differentiate when we use a subnet mask for like an IP address configuration and a wildcard mask for other types of things like configuring network command for routing protocols or access control lists. All right, so let's look at some basic EIGRP configuration. So here on router R1, we're just using the class B, so that's a /16 by default. So basically this network statement would say for router R1, any networks that R1 has, any interfaces that R1 has an IP address beginning with 172.16, anything will be enabled for EIGRP. Better example here is network 10.0.0.0. That's a class A or a /8. So we have two interfaces that fall under the two interfaces that are subnets under the 10.0.0.0/8. So it's just a quick way of enabling all interfaces with a single command. I don't typically like that. I like to be explicit in what we're enabling. All right, so here's R2, similar configuration. But let's get to R3. R3 uses the wildcard mask. So it's actually specifying this network address for this subnet, this network address for this subnet, and this network address for this subnet. Okay, again, it's using the wildcard masks, okay? And that's how it determined the wildcard masks. Yep. /29 is 255, 255, 255, 248. Subtract that from quad 255, and we get the 0007. Okay. So I think it's always best practice to be explicit and use I'm generalizing here because there's some advantages to just if you're configuring a lot of interfaces, you want to do it on a single command, but I like to be explicit. All right, the router ID. So the router ID is, a unique value to identify each router in the EIGRP routing domain. It's a 32-bit value, okay? Now, we sometimes think it's an IPv4 address, but we represent it as an IPv4 address, but it's just a 32-bit value, okay? So how does it determine the router ID? Well, if we have configured the router using the EIGRP router ID command, that's under EIGRP, then that will be the router ID. And that's really what you should do. You should be explicitly configure what the router ID is for each router. But if you did not use this command, it will use the highest loopback IPv4 address on the router. If there are no IPv4 addresses, loopback IPv4 addresses, excuse me, then it will use the highest active interface IPv4 address. That interface does not have to be configured or enabled for EIGRP, but it will use that interface's value as its router ID. Okay. But it's best to always explicitly configure it, and this is how you would configure it. Okay. So showing router R1, R2, and R3. So here it's just showing that when we changed the router IDs, that it formed a new adjacency with those routers. Okay, passive interface. Okay, so there typically will be some interfaces on some routers that do not have neighbors, like our local area networks, or do not have EIGRP neighbors. We don't want to be sending hello messages out there, but we still want to advertise those networks in our EIGRP update so the other routers know how to reach that network. So we want to include it as a network statement, an EIGRP network statement. We just don't want to send out hello messages out those interfaces. So we can suppress the hello messages using the passive interface command under router EIGRP. All right, so that's the basic EIGRP configuration. We'll look at some more advanced configurations in later videos, along with how to verify this configuration.